Hey guys, welcome back. For today's video tutorial, I'm gonna work on a new sensor that is MMA7455. We have been working on different sensors, digital sensors, and this is a new sensor which we're gonna work today. And to gain more knowledge about this sensor, let's have a look over this sensor. For that, we have to log on to the website www.controleverything.com, and here we have to search for this particular sensor that you can see. And here let's have a look over that and see what we got for this particular sensor. And we got that MMA7455 is a 3-axis low G, low gravitational digital output accelerometer. As you can see, these are some of its features, and please have a look over that. And you can also purchase this sensor from here. Now I'm gonna display the interfacing of this sensor MMA7455L with a particle photon, and for that I require a particle code. And let's have a particle code sample here. Now you can download the particle code sample as a zip file, as you can see on my screen. Yeah, from here. Now you can also have the opportunity to download the code from our github.com repository, that is Control Everything community. Now what we require for this video to work is that some hardware along with the sensor, and let's make the connections for that. Now this here is our sensor, that is 3-axis accelerometer MMS7455. Now what we require is a particle photon, which you are able to see on my screen. Now the question arises how to make a connection among the sensor and the particle photon and other I2C devices, and also make this connection a lot easier. So this comes an I2C sheet. This is available on the website controleverything.com, and you can gently put over the particle photon over the I2C shield and make this connection. Now what we require is a connecting cable which acts as a binding factor so that we can connect the sensor and the I2C shield. And the rule is that while making this connection, we have to ensure that the brown wire of the cable should be connected to the ground terminal of the sensor. And similarly, we have to follow this set of rules for I2C shield. Now finally, we have to power up our particle photon, and a micro USB cable comes into the picture. Now gently insert it over the power jack. Now we are done with the connections part. Now let's have a look over the particle code so that we can interface and work with our sensor. Now for the interfacing, I will be displaying the working of this sensor using a particle code and particle photon. For first of all, to get the code, get into github.com and here search for the repository, that is Control Everything community, which you are able to see on my screen. Now get it over and here search for the sensor, that is MMA7455, as you can see. And here we got our sensor, that is a 3-axis digital output accelerometer. Now this is the code we are looking forward, particle code. But before that, let's have a look over the instructions we need to follow. We have to log into a particle photon and set up the device, as you can see, and the steps are being provided on this web link. Now second, we have to download the code, and on the online ID we have to copy this code. And build.particle.io, build is the link where we have to copy this code and save the code. Now at the very end, we have to verify and flash the code on the particle photon, and the code output will be displayed on this web link, as you can see on my screen. As you open up this link, there will be output display on the screen. Now please do it carefully and follow through. Now get back to the code, which we insist to have the explore. Now it's a .in extension file, as you can see. Now the first thing you notice that we have included application.h and spark wiring I2C.h header files, which will have certain functions which we will introduce later in this code. And we have defined the address of the sensor, that is 0x1d. Now we have some variables we have initialized and set here some variables, as you can see on my screen, in the void tagger function. Now we have initialized I2C communication as master and serial communication, and the baud rate equal to 9600. Now comes the writing section part, where we have selected the mode control register, that is 0x16, and here we have the measurement mode plus minus 8G. That's the gravitational pull, and the command for that is 0x01. Now as we are done with this part, let's have a look over the void loop function, as you can notice, and we have selected the data register, that is 0x00. Now from this very register we have requested and read 6 bytes of data which include X, Y and Z axis of the data for accelerometer. We had read the values and we calculated these values, and here comes the conversion part of the data into 10 bits. Now X, Y and Z axis data is being converted and the values are being stored. Now at the very end of our code we have output data on the dashboard in the form of acceleration in X, Y and Z axis, and it's perfectly formatted so that we can have a total understanding of this, a very generalized and simple code. So you can have a go through look over the code for any clarifications, and let's have a look over how this code practically works. So let's have a look over the practicality of this code, which is very interesting as you can see. For that, copy this entire particle code of the sensor and then open up the terminal. Here build, as you can see. Yes, here we got it. And here we have to create a new file, MMA7455, and here paste the entire code we have just copied, save the code, and now verify and compile the code. It's a good work. And now we have to check for the flash, which we have to check for the magenta flash, and here we have it's a successful. As you can see, it will have the consequences of having the data output to be displayed on the dashboard. So let's open up the dashboard link and we can have the output details on the screen. Now as you see, we have the acceleration in X, Y and Z axis and it's coming on. As you can see, it's almost stable. There's a very minute change regarding that. Now when I try to move the sensor, there will be changes in acceleration for the direction X, Y, Z, which are perpendicular axis to each other. Yeah, changes are being on the monitor and the dashboard. As you can see, it's constantly changing when I'm rotating and moving the sensor. So this is how the sensor MMA7455 accelerometer works with a particle photon. So what we require is to have a look over the benefits and the applications regarding this sensor. So we are done with the working of the sensor MMA7455. Let me tell you, MMA7455L is a digital output, low power, low profile, capacitive, micro-machined accelerometer featuring signal conditioning, a low pass filter, temperature compensation, self-test, configurable to detect 0G through interrupt pins, and a pulse detect for quick motion detection. So these features make it very important for a lot of applications like cell phone, PMP, PDA, image stability, text roll, freefall detection, pedometer, motion sensing, and a lot more. This sensor can be purchased from the website controleverything.com, and the relevant code is also available on the same site. You go to the source tab and here comes the sensor code. Now you can also get the code from GitHub repository, that is Control Everything community. So at the end of this, I just want to make it clear that in case of any further queries regarding any part of this sensor or any video part, you can contact me on controleverything.com and you can post your comments on the community page of this website. Now for articles and blogs which are relevant to this video, you can have a go through look over instructables.com, and to subscribe more video tutorials which are coming through, and for this video tutorial you can also subscribe onto our YouTube channel. So at the very end of this, I hope you enjoyed this video and yourself have a good one. Thanks a lot for watching.